4. It's not even a whole line. Identify lines. And then look out, I don't write that. We had to look back and forth.
Okay, homework question.
I know what it's already asking.
There's graphs. All graphs go on graph paper. Like the whole year, it's nothing new.
Wait, there's no credit on graph?
You get partial credit, but this has been the whole year. The whole year. All right, so what do we got? 1 through 4. Horizontals, obliques. What was the... Say it again. The answers were online, but so you should know what you had questions on. Yeah, Sophie. Number 4, the whole thing? Shh. Okay, can I borrow this, please? I don't have it written down. Oh, okay, so first thing I would always do is factor, and then hopefully something reduces. It makes the asymptotes a bit easier. So, cubes, difference of cubes, so it factors as x minus 1. You tell me. X squared plus x plus 1. Minus plus plus for the difference of cubes. And then keep in mind the a squared plus or minus ab plus b squared. This is never factorable over the real number system. So don't waste your time. This is never factorable over the real number system. So don't waste your time. Okay, so Sophie, I don't know the order that they asked you to find stuff. I'm just going to do the whole thing. Okay. Anything reduce? Any reductions? Nope, so there's no holes. Nothing reduces, there are no holes. So let's look at vertical asymptotes. What values of x make the denominator 0? 3 and negative 3. How about x-intercepts? 1, 0? Yeah? Y-intercept. Go back to the beginning. It's much easier to find the y-intercept in non-factored form. X cubed, 0, x squared, 0. You're left with 1/9. You can find it by plugging in 0 to the factored version, but it takes a little bit more time. Also 1/9. Okay. So here comes the issue, and that's the horizontal asymptote. The horizontal, y equals 3, y equals 16, y equals 0. That's the horizontal. Oblique, y equals mx plus b, something with that. All right, so what about this one? What's the lead coefficient in the numerator? What's the lead coefficient in the numerator? 1, and then it's x cubed. Sorry, the lead term is x cubed. Blah, 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 blah. I don't care about that. I only care about the lead term. Denominator? X squared. Yes? Okay, so when you reduce that, what do you get? You get x. When you reduce that, you get x. What kind of line is y equals x? It's a diagonal line. It's oblique. So what am I going to do? Long division. I can't do synthetic. How come I can't do synthetic? There are numerous, well, I shouldn't say numerous, there are 2 vertical asymptotes. So if you're going to synthetic, should I use 3? Should I use negative 3? Here. Which one should I use for synthetic division? You don't know. You have to long divide. I'm gonna put in 0 x's. Okay, go for it. If you get into the long division, you can't find the asymptote. Go for it, or tell me what it is.
X.
There's no, the y-intercept is 0? The y-intercept is 0? Yeah, okay. So I'll just start it for some of you who are confused. X. X squared goes into x cubed x times. Distribute. Does x squared go into 9x? No. So this is the remainder, which we don't care about. We don't care about the remainder. So I have an oblique, fancy word for it's a diagonal line. Be super careful how you plot the oblique asymptote and the verticals. What's the x-intercept? 1. Where's the x-intercept? 1, 0. Here. And the y-intercept? Positive 1, 9. There is only one option for between these two asymptotes. Up, up, down, down, up, down, down, up. Only one choice. It is up, up, down. How come?
I mean,
This is an M. Okay, but why does it only make sense? Like, how are you going to explain that to somebody? Why can't it go down up?
It's going to cross the axis.
That's exactly right. Always look at your x-intercepts. Your x-intercepts will help you greatly. And we can't cross the x-axis here. Da, 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 da. I'm not even going to put in the, the oblique yet. What's the multiplicity of each asymptote? 1, which is odd. Agreed? Odd, opposite. So at 3 and negative 3, we're going the opposite direction. So I'm going to partially erase this in a minute. To the right of negative 3, the graph is approaching positive infinity. So what's the opposite of approaching positive infinity? Approaching negative infinity. So this side has to go down. There's more to the graph. I'll draw it in a minute. The right side, or the positive 3, the right side approaches negative, so the left side has to approach positive. Are there any more x-intercepts? There are no more x-intercepts. This is not 100% correct. Did we plug in any points? You don't need to. You don't need to plug in 1 point. But there's a problem with this, and that is I never drew in the oblique. Okay, only part of this is correct. So the oblique slope is 1. Yes? Okay, so I have to approach the asymptote, which means I definitely need to fix here. It's a pretty bad curve. There's something else wrong with this graph. Yeah, Tommy. I can't hear you.
The oblique is, it's only approaches, it's not like a vertical asymptote.
Okay, so the oblique only approaches, it's not a vertical asymptote. I don't quite understand what that means.
Like you can't plot the oblique through the graph.
You can't plot the oblique through the graph. Keep going. You're almost there.
It's like, you know, it has to be like infinitely that way. But
It has to be
It's like
infinitely
horizontal.
that way. Do you agree that like it's end behavior, so it's approaching infinitely that way? What about infinitely that way? Is that okay?
Yes.
Sammy.
The graph can cross oblique or horizontal asymptote as long as it's not as close to infinity, because as it approaches infinity, it gets closer to it, but before that, those numbers will matter that are like the blah blah blah. So
The blah blah blah. You're making fun of my blah blah blah.
I'm not making fun of them.
Okay. End behavior. Okay. End behavior. That describes what's happening as x gets huge, like infinity. Yes? Negative infinity. So, I hate to break it to you, but 3 and negative 3 are not infinity. 3 and negative 3 are measurable values, yes? So, you draw the oblique, horizontal, end behavior, whatever it is, through the vertical asymptotes, we're not going to get full credit. And why is that? Because infinity is like way down here. And negative infinity is way down there. 3 and negative 3 is like here. So if you draw the oblique, horizontal, and behavior in between vertical asymptotes, nope. No can do. Yes, Rebecca.
How many orders of magnitude does it have to be?
I don't know. Down there. Like as far to infinity you go, you can go farther. There's infinity plus 1. Like you can go further and further. Where is that? I don't know. I am Miss Babiak, a regular old Algebra 2 honors teacher. I do not deal with orders of magnitude of infinity. Got it? All right, so there's number 4, I guess that was. Okay, so I'll be happy to go through more questions. I have a couple of announcements. First, the AMC, Thursday, 6:45 a.m. Thursday, 6:45. So if you signed up, which several of you did, tutorial center, and you need to go in through the back door because the library itself will be closed. Okay, Thursday, AMC, 6:45, back door. All right, next, the homework for tonight is on Classroom already. So if you want to start on that, feel free. I'm going to continue to go over questions about whatever you have questions on. Okay? If you have questions, let me know. And I'll collect it in a minute. Tell your teacher name. What class? Alright, sit down. Fine. Take out some more. That'd be great.
Can we go over question
3? You were going to have a question. You're right? I can do 3 first? Okay, great. 3. Okay, so I'm going to do number 3. So if you don't have questions, that's great. If you're working on the homework, that's great. But you need to keep it down so that people can hear me that want to hear me. All right, help me out. What's number 3?
X plus 2 over x squared plus 4x plus 1.
X plus 2 over. Keep going, Elliot.
X squared plus 4x squared.
This one has a unique asymptote. Fantastic if you're working on the homework, but please try to keep it down because other people have questions. Let's just go straight to the asymptote. Yes? Are you sure?
Yeah.
No, it's not, because in the 4th period, they were all working on the proper homework. Did you click on the right day?
Yeah.
Sure,
It happens when at home. It happens when home computer.
Okay.
It just loads like.
Do we have the correct homework? It's different than last night's.
No, it was like.
I think it's
stuff.
No, we already did.
All right, hold on, hold on.
I told you that. Yeah, I know.
Okay, so